I'm Phil Dodge, and I work at Constellium's research lab in Plymouth, Michigan, USA. We're in the Detroit area to be close to our automotive customers. I have 10 years experience as a metallurgist in Constellium, helping create advanced aluminum solutions for the automotive industry. Lightweighting for vehicle design requires balancing three main pillars: performance, energy usage, and cost. Among the many levers that automotive engineers have to reduce energy usage, reducing the mass in the vehicle is one of the most effective ways to cut energy costs across all driving conditions. In both electric and internal combustion engine vehicles, lowering mass leads directly to energy savings and leads to further downsizing opportunities, like reducing other components. In battery electric vehicles, the battery is the heaviest and most costly component, and reducing overall vehicle mass has a big impact. When we run the numbers, we see that a 10% reduction in vehicle mass reduces the energy usage by 4 to 5 percentage points, which is significant. And you can expect to achieve a 10 to 15% reduction in vehicle mass when you transform a steel-intensive construction into an aluminum-intensive vehicle. This allows automakers to reduce battery size without impacting range. Smaller batteries mean less cost and further weight reductions, creating a virtuous cycle that leads to not just battery savings, but also reduced performance needs for other components like the brakes, suspension, and motor. For internal combustion engine vehicles, a 10% drop in vehicle mass results in around a 3 to 4% drop in the fuel consumption. If engineers take this a step further and can downsize the motor while maintaining the same performance goals, you can achieve up to 6%. This dual effect makes lightweighting a powerful tool for meeting fuel efficiency regulations and reducing emissions without sacrificing performance. In city driving, rolling resistance is a major source of energy loss, accounting for about 30% of energy consumption in battery electric vehicles. Rolling resistance is directly linked to the weight of the vehicle. The heavier it is, the more energy it takes to keep moving. Lightweighting reduces this friction, making battery electric vehicles especially more efficient in city driving conditions. Aluminum offers an exceptional strength-to-weight ratio, making it a prime candidate for both structural and cosmetic vehicle parts. It's 1/3 lighter than steel, and when used strategically, can help manufacturers remove about 30 to 50% of weight from a vehicle part, depending on the application. It's also highly recyclable, helping achieve the auto industry's sustainability goals. Aluminum is naturally less stiff than steel, about 1/3 the stiffness, but that's not a deal breaker. Since bending resistance scales with the cube of thickness, a 44% increase in the thickness of an aluminum part can match the same stiffness as steel. Even with this added thickness, the resulting part can still be about 50% lighter than steel. This makes aluminum ideal for applications where resistance to bending or flexing is critical, such as hoods, doors, or roofs. In areas that demand high strength, such as crash zones or structural reinforcements, aluminum still shines. While advanced high-strength steels are often used, aluminum alloys like those in the 6000 or 7000 series achieve comparable performance. Through increasing thickness by 50 to 100%, aluminum can offer 30 to 45% weight savings while maintaining the required strength. Aluminum is infinitely recyclable without degrading its properties. This makes it a cornerstone material to help the automotive industry's push towards carbon neutrality and circular economy principles. Every kilogram of aluminum used smartly can help reduce the overall carbon footprint of the vehicle, especially when paired with renewable energy used in its production and recycling. As EV adoption grows, aluminum's role becomes even more important. The need to reduce vehicle weight, improve range for drivers, and meet tougher sustainability targets makes aluminum essential for next-generation vehicle platforms. It not only helps with energy efficiency and performance, but also aligns with the industry's drive towards lighter, cleaner, and smarter mobility solutions. The key takeaway is that lightweighting with aluminum is not just about reducing weight. It's a multifaceted strategy that improves fuel economy, battery efficiency, cost effectiveness, and environmental impact. Whether you're designing ICE vehicles or EVs, aluminum opens doors for better vehicle performance and smarter engineering, now and in the future.